This podcast is brought to you in partnership with EVA International Media Limited. Hello and welcome to Down to Earth with Terry Birch, where we talk about what matters down here on planet Earth. And today we're going to talk about what matters in orbit around planet Earth. I'm super excited to have Ed Lu, a former colleague of mine. Dr. Ed Lu is a former NASA astronaut and veteran of 2 space shuttle and 1 Russian Soyuz mission, having spent 7 months in space in total. Since leaving NASA a few years ago, Ed was the leader of advanced projects at Google, small company you may have heard of, and he co-founded the B612 Foundation that is to detect and track asteroids that might possibly threaten Earth. And he's also the co-founder of a company called LeoLabs that is dedicated to helping satellites in Earth orbit avoid space debris. Ed, thanks so much for joining us today.
Thanks, Terry. It's good to see you again.
I know it's been too long. Good to see. Thank God for Zoom. Hey, I see your Matryoshka dolls in the background.
Oh yeah, everybody's got a set of those. If you're right here, right?
I think mine are in a box. Yeah. So when are you gonna do something with your life, Ed? When you have like family get-togethers, are you like the black sheep because you've been just slacking off for so long?
That's a good question. My wife keeps asking me that same question.
Well, there's so many things we could talk about. I'd love to talk about just share space stories. We probably have some good ones. There's 1,000 things, but let's focus on debris. I know you're a busy guy, and space debris has been a big topic of mine. I think it's the number one issue facing humanity that we don't talk about. And so in my brain, I categorize them as a couple of different things, and then I'll let you talk because you're the master. You've got asteroids that might hit Earth. That's like a pretty significant threat. On our old risk thing of likelihood and severity, that it's not very likely, but it's pretty severe.
That's right.
Yeah. There's smaller space rocks, and those things hit the station every once in a while and leave little dents in the aluminum outer structure. They can hit satellites and damage them, but these are like things that come from the solar system. They're rocks or dust or whatever. There's also other space debris that we've left in space, paint flecks from rockets and that kind of thing. There's deliberate military space debris. I mean, our Russian and Chinese and Indian friends have been busy with that recently. And then there's Starlink, and I want to keep a special category for Starlink and these mega constellations of tens of thousands of satellites. So in my brain, that's how I categorize these things. And you've been working on a lot of these things, and I'll turn the floor over to you.
Sure. Yeah, I agree with you that the biggest potential impediment to the development of space infrastructure is orbital debris. And in the case of orbital debris, nearly 100% of that is human-made. So this is not, it's a tiny fraction of the stuff that comes through Earth orbit is, even though it's a substantial amount of stuff, 20 tons a day comes and hits the Earth, but it's mostly dust, things like that size. But things that present a danger to our satellites, to our development of space and the services in space is really man-made junk. And it's not active satellites either. Active satellites are a small fraction of what's up there. Most of the objects up there are just leftover parts or dead satellites or parts of collisions or ruptured rocket bodies or things like that. I can actually show you if you're interested. I can share my screen. I've got a live image from LeoLabs, not image, but depiction of the last 24 hours of data.
Okay.
Of everything in space.
Let's see it. We have YouTube viewers, but we also have audio only viewers, so you'll have to describe it for them.
Okay. Let me see if I can share my screen here. And
while you're doing that, and on my spacewalks, I saw a bunch of little craters and stuff out there. In fact, one of my task list items was to put a clamp on a handrail where there was a big crater that was like sharp. You know, they didn't want someone to cut their glove on it. So you're saying all those little things are probably pieces of satellites or flecks of paint from rocket stages and not interstellar or, you know, rocks from the asteroid belt or anything like that.
Yeah, that's actually correct. So what I'm showing you here, if you can see,
I can see it now. Yep.
It's an image of the Earth's globe. It's live.
Wow.
Well, it's the
Yeah.
last 24 hours of data. So every one of these is an object that LeoLabs is tracking. The
Oh,
red
wow.
beams are where our current radars are, and those are the beams. And so what actually happens is, as these objects go through the beam, we recalculate their trajectory. So, and you know this from flying around the Earth. If you're in whatever trajectory, you're going to pass through one of these beams multiple times per day. So every one of these objects gets retracked multiple times per day, every few hours. And we update its orbit. Their orbits do change because there is, as you know, a little bit of drag up there that changes the orbits of things, but there are thousands of objects. So
I like the galaxy in the background there. You can see the.
Yeah, it's actually anatomically correct. This is actually in the proper location there.
That's
so
amazing.
What I'm showing you here is the thousands of objects, and the objects are depicted larger than they actually are, because otherwise on the scale of this you wouldn't see these things. You know, these things tend to be meter-sized objects or so.
But meter size. Okay, so
yeah, or you know, spacecraft sized, down to small things
bag or small car or something like that.
Yeah, down to actually things down to the size of, you know, a softball.
That looks like a coronavirus.
It kind of does, except everything's moving. So let me clean this up a little bit. We can show this to you any particular way. So let's just name a satellite here. I'm going to type Zarya, which is the first module launched of ISS, and we can see where it is.
So we're looking at a globe. It's kind of like looking at Google Earth of the entire Earth.
Yeah.
There are interesting patterns. The radar patterns I'm just describing for doing play-by-play for the listeners look like fans sticking up from the Earth, and then there's the interesting like hexagon pattern where the radars are looking up.
There's ISS going over Australia.
Oh, there it is. Yeah, it's moving fast.
Yeah, you'd mentioned Starlink, so let me show you that. These are all the active Starlinks that we're tracking.
Holy crap, there's a lot of Starlinks up there.
Yeah, it's about 2,500, I think, of them. Okay, so there's some interesting things to note here.
Wow.
See these trains? There's a whole bunch of them in a row here.
It looks like an ant mound that you just kicked over, and the ants are just.
But they're all marching in rows. Look at that.
Yeah.
It's like those marching bands on the field you see, where, in fact, it's a very similar analogy because they're essentially one giant formation.
Right.
And that means you can actually, if you coordinate, if you know where everybody else is, you can actually vastly increase the density of spacecraft. In the same way that if I had a football field full of trained marching band members, I could have an awful lot of them on there, and they can actually coordinate their movements. If everybody's running haphazardly, then collisions are going to happen. So the key here is coordination. It's not the number of objects; it's the coordination. So,
well, you can only coordinate with a satellite that's working.
True.
And what percentage of I read the SpaceX Starlink plan. Their plan is to deorbit them, bring them closer to the Earth, so that the atmosphere will bring them down within 30 years. Is that true? Is that their
no. It's like 30 days.
Okay.
These things are very low altitude. Such that, well, maybe not 30 days, but it's probably depends on where you catch them. But there's a couple different altitude bands, but it's well under a year. It's probably in the months time frame.
You mean if they die?
Yes, they drop out naturally very quickly.
Oh, they're up at like 1,000 kilometers or something.
No, 520 kilometers.
And if you're 300, that's higher than the ISS.
That is higher than the ISS, and the ISS is in a very high drag region, remember. So the lifetime is really increases as you gain in altitude. Yeah. So by the time you're 1,000 kilometers, that lifetime is in fact decades.
Right.
At these altitudes, it's literally months. So which is why they're in this altitude, because SpaceX realized that and applied to change their constellation to a lower altitude, which was granted for exactly this reason.
Okay, so they have a plan that's not going to. Do the satellites actively deorbit themselves, or
they do, but if one dies, you just have to wait for a few months, and they will deorbit.
For some reason, when I was reading about them, there were several tranches. You know, the first ones were going to be low, and there were going to be some that were in a much higher orbit. I don't know if I read a wrong. I read that. I don't know
They
if it was wrong.
changed that to that they're now going to ones even lower than this. So
Okay.
make them drop out even faster.
So are they actively reboosted now?
Yes, they're continually actively boosted. Each one of these runs on its own, has its own coordination. Because with this many spacecraft, and what you're looking at here is thousands of them, right?
Yeah. Oh, yeah. It's a lot. Like
They have to autonomously operate, sort of like a self-driving car. They get positions of each of them, and the tracking company is LeoLabs. It does this. And based upon that, and we also send them up the positions of any space junk that might be on a potential collision path with each one of them, updated. I mean, there's hundreds of thousands of those per day, but those are, and then a decision is made on board each spacecraft whether or not it's going to change its thrust profile in order to automatically miss those.
Do they use electric ion thrusting, or okay?
They do indeed, yes.
So there's like a continuous small. It's like just barely pushing on it.
Yep. It's like you have to maintain this. You know, it's kind of
Right.
like flying in formation. That, you know, with something
Right.
you're familiar with. You
Yep.
have to make lots and lots and lots of small changes, and that's basically what they're doing here. One of the interesting things I want to point out here is there's these groups of things that look like trains. You see like this, a whole bunch of them in a row. Here's another one, a whole bunch of them in a row. And those are ones that have been launched recently, such that they haven't yet had a chance to, as they raise them up in orbit, they also spread them out. So this one is launched probably, you know, this train that I'm pointing at here of, you know, this is 60 satellites in a row, probably launched maybe 2 weeks ago, or there's this one here, that may be the one that was launched, I think it was Tuesday night, Wednesday night, something like that. But
well, they've got 2,500 now, but they're eventually going to go to tens of thousands. I think that's why correct. They need the BFR Starship, right?
Yep, that's correct.
The numbers.
Yeah. So we can show you, I can show you anything else too. Like for instance, here are all the Russian ones.
Oh, you can look at Russian satellites.
Yeah, these are all the ones with the designation Cosmos.
Right. There's a lot less. There's a lot less of them.
Let me show you the Chinese ones.
Future Starlink. Oh man, there's hardly any Chinese.
Well, this one type. I'm just typed in one called Yaogan. I could also do it by country of origin. I could do it that way. In fact, one interesting thing is that the Chinese are launching very nearly as fast as SpaceX. About every 6 days, the Chinese launch.
Yeah, they're making their own. I wanted to talk about that. But to get back to Starlink, future Starlink tranches are not going to be above 500 kilometers is kind of the max.
They might be doing another one, sort of mid 500, 550 or something like that.
But it won't be 1,000, because once you get up to 1,000, you're there for you're there for a long time, right?
Yeah, there are other constellations that are that high though.
Right. So Airbus is doing one, right? I think maybe Boeing.
Chinese. Iridium is at that altitude.
Yeah. So what altitude are the Chinese going to be at?
There are 3 or 4 that I know of Chinese constellations, and they're at different altitudes. So we'll see where they end up, because they have not yet begun launching those 3 particular large ones. One of them is something like 30,000 satellites.
At what, you don't know what altitude that'll be at?
I could look it up, but I don't, off the top of my head, I don't know.
In my mind, Ed, that's a really important thing, because you start just creating a mess that'll be there for centuries, right? Or forever above a certain altitude.
Here's the let me just put this in perspective for you. This is the the active satellites. Let me just show you the debris objects.
Again, a lot of people are listening, so we'll have to describe it.
Okay. There's more debris than everything else.
Okay, so these are not intact satellites. These are just
debris outnumbers satellites by a factor of 10 to 1.
Wow.
Okay, and that's only for the ones. What I'm showing you here is things that are in the so-called public catalog. And that means that they are also tracked by the U.S. Department of Defense, who maintains a catalog they call the public catalog. But it is only objects larger than roughly 10 centimeters in size. Okay, so a size of a softball. That's their capability. Now we have the capability to go smaller, but we're not yet showing those. But here is the issue for our compatriots on space station or anyone flying in space. When we were there at NASA, the number one risk to in the risk assessment, they called it the PRA.
Right. Probabilistic risk assessment.
Yep. Exactly. Was being hit by orbital debris on ISS. In fact, the odds of a rupture, well, a loss of crew, the LOC odds for space station over a 10-year period is something like 1 in 60. And so that means everyone dies, right? So that means something
There's
comes to
1 in 60 like loss of hull airliner type of accident. 1 in 60.
Yes, that's been the same since start of the program. That has never changed. And you know why? It's because the vast majority of stuff that can come through the hull is smaller than 10 centimeters and is not tracked by DoD. Okay, right. There's about 200,000 pieces of debris up there that's bigger than a golf ball, but smaller than 10 centimeters.
Right.
That the Department of Defense does not track.
Right. Well, and you're talking like a radar cross section. If it was a big piece of plastic, the size of a room, you might not see it. And if it's a little reflector pointed at you, you might see it. But that's
correct. Yes.
That's a rough size.
Everything has to be done in terms of its radar size, which is can be slightly different. You're right.
Right.
But still, that doesn't change the fundamental fact that this risk, the reason we're carrying this risk is because the Department of Defense does not have the capability to track nearly all of the objects that would be fatal if they hit you.
Right. And we don't have a radar. It's not like the ISS goes, hey, there's a debris coming, and it moves. It's all done by tracking on the ground.
If you knew about it, you could, but they don't know about it.
Right.
That's why we founded our company. We explicitly designed our radars to be able to track down to 2 centimeters, which is about the size that can come through the hull.
So you own a portfolio of radars around the globe, your own radars. You're not getting these from Space Force or anything like that.
No, these are LeoLabs, designed, built, operated, funded, everything. And we take it all the way through. It's not just having a radar. You have to break that down, calculate objects, calculate their orbits, decide where they're going, create the maps, make the warnings, all that other stuff. So that whole process is what we've built. We've built a civilian version of this, which we believe is going to be far superior to anything else on Earth. And we're still building it out. We thus far only have let me see, 1, 2, 3, 4, 5, 6, 7 radars operational right now. But we have quite a number more in the works that you can expect that number to grow very substantially by factors of several over the next 2 years. They're already, we have a number of other radars already under construction.
Wow. And you sell data to companies so they can manage their mega constellations like Starlink.
Yes.
Or does the government want your information, or?
We do provide services to the U.S. government, yes, as well as allied governments.
But not China.
We do not. China is not a customer. No.
That's good to hear.
Yeah, we are very careful, who we provide our services to,
right?
Because you can use this for a lot of things besides just this is also useful to the people who insure spacecraft, because there are such thing as, quote, bad neighborhoods. There are altitude ranges and bands that are very much higher risk. There are long-term risks of in certain types of orbits that we can pinpoint. Also, as you might imagine, many of these things could be active satellites that are that the U.S. government may wish to monitor very, very closely, for instance.
Right. And if they're changing orbits, if they're following other satellites, there's all kinds of interesting things they can do. Can our listeners go to LeoLabs.space, LEO, like low Earth orbit?
Yes. And if
LEO, LABS.
Yep. And through there we have, this is public. You can search for this visualization. It's if you just do a search on LeoLabs and visualization in Google, you'll find it.
Yeah, it's really cool. There's a really big issue for me, and I want to get your take on it, and that is, it feels like with companies like Starlink, it's just a race. It's the Wild West. Get the satellites up there before somebody regulates it. There's U.S. government regulation, which ironically the FCC has a lot to do with, but there's
some
not.
of it. Yeah, only some of it. Yeah, they have frequency licensing and they have launch licensing, which is supposed to take into account debris, because there was a power vacuum. Nobody was in charge of that.
Right.
And the switching over to the Department of Commerce, they're in the middle of that right now.
Right. There's the Department of Commerce, the FAA, the FCC. It's NASA really doesn't.
No, NASA's not a regulatory agency. They don't regulate anything anywhere.
Right. So when we fly to Tokyo or when we fly to Paris or whatever, there's the ICAO. All the pilots say, I'm number one, ready for takeoff. You're clear to land. Line up and wait. Used to be on to hold. Now it's line up and wait. Right. There's all these standardized procedures, and we can go everywhere in the world. And you have to have an extra crew, and the crew rest is 10 hours, whatever. There's not that for space stuff.
No, there isn't. But again, the real things you need to do to sort of get a handle on this are three things. Number one, track better. You need to know where everything is, because if you can't see it, if you don't know where it is, you can't avoid it. Okay. Number one. Also, because if you can't see if anybody's creating more debris, you have no idea. There's no incentive for someone to have good behavior in space if you knew that nobody could see you. Okay, so number one is better monitoring. In the same way that if I told you on I-5 in California that there was no monitoring, no way, no radar for anybody to tell how fast you were driving, what would people be driving on I-5?
You try I-45, and about a year ago, the cops stopped policing I-45. It's been the Indianapolis 500 here ever since then.
Exactly. So monitoring is the number one thing. So there's three things we need to do. You need to monitor better. You need to not create more debris, which means don't launch satellites that are going to die. Don't have satellites that can have like tanks that rupture and things like that. So this is a design thing on satellites. And the last thing is, if you look at the long-term risk of additional debris, it's really given by the mass of an object in space, right? A big object, if it breaks up, and eventually it will break up. If it doesn't come in, it will break up.
Right.
Is the amount of potential debris is just given by the mass of that object. So if you actually calculate the risk, which we have, of the riskiest objects in space, which are dead, cannot maneuver, and at an altitude where they're going to stay up for a long time, which we have, then you find that nearly half of the debris risk of future debris in space is actually from like 50 less than 100 objects, roughly 50 objects. Okay. And they're all spent rocket stages or very, very large satellites that are defunct. Okay. That means you could actually remove those from orbit, meaning you take something that can bring it down, and you would cut the risk in half of future debris. Now, as long as you don't create more debris, remember, satellites naturally come down, especially at the lower altitudes. This problem is absolutely something we can work around. We can.
Yeah, let me restate that, Ed, to make sure I understood it, because I think you just said something really profound. There's all these startups and they're trying to work on space debris, and I've always thought there's 50,000 pieces of space debris. You're not going to go clean them all up. But you're saying if you could clean up the 50 most egregious offenders, you could get rid of half the potential space debris. That's really,
and it's even better than that.
Lifeless.
The smaller something is, the higher its ballistic coefficient is.
Right.
Which means it comes down faster. The smaller stuff comes down on its own. The big stuff does not.
Well, to a certain altitude, right?
Up to a certain altitude. Yes, this is all
talk altitudes. What altitude matters?
Yes, but at any given altitude, the smaller you are, the faster you come down.
Right.
So what that means is, if we just stopped creating more debris, the lower altitudes will clean themselves out. And those are the busiest altitudes for other spacecraft. The big ones you remove, and again, this is something that could be done. and better tracking is on the way. LeoLabs is building more radars. There are other companies doing this too. So we're going to make it. I think we can solve this problem. That's the encouraging aspect of all this.
Through better tracking, actively deorbiting the big offenders.
Mm-hmm. But remember, the order is 1, 2, 3. The most important thing is tracking. The second one is don't create more debris. So that's given, and that is incentivized by better tracking. And the last thing, the thing that is the least benefit, is actually removing the debris.
Right.
It's still important, but it's number 3 in terms of, if you look at the risks, you just line up the risks, and there that you got, those are the 3 things you need to do. And so,
not creating more debris, though. When I was a commander of the station in 2015, we had a maneuver to avoid debris that the Chinese had created in 2007 on that famous test. There were defunct Russian satellite hit the Iridium a few years later, and recently India did the test, and worst of all, Russia, right before the war, they've lost their mind in Russia, and they did that military test. So you're talking about accidental, nice, well-intentioned satellites that just die. But there's another, I would say, another thing in your 1, 2, 3 is quit with the military tests. America just committed, I think, unilaterally to not doing more.
No argument here.
Yeah. But again, this goes back to the international regulation environment, and the UN, of course, is very weak. There's nothing. Your number 2 thing, to design satellites that don't just get stuck up there. There's no regulation to require that, right?
Yeah,
China
exactly.
has to be.
Yep.
Yeah.
But actually, there are regulations. It's just routinely flouted because nobody's monitoring it. Again, we come back to nobody's monitoring it. Nobody's job it is to look for this. So let me just show this to you. What I'm showing is the Cosmos 1408 debris. This is the Russian ASAT test from about 8 months ago. Yep.
Yeah.
And you can see how many pieces there are.
Holy cow! There's like a belt of around Earth of all these red.
They all stay in roughly that same inclination orbit. But they spread out depending upon their altitude. So it forms this sort of belt around the
What
Earth.
altitude?
Most of it's in the range of around 500 kilometers. So some of it does come down towards where ISS is. Most of it is above ISS.
And how long will that debris be there?
Depends on the size of each piece and its altitude. So it is getting
months or years.
Pieces, years.
Yeah.
It's already been a year, and look how many are still up there. So
there's lots. We're looking at Earth with I couldn't, maybe hundreds of red dots we're seeing move around Earth. So I'm a big advocate of having some type of regulation. What your number 2 thing, again, design your satellite to deorbit itself.
Well, it's not just design it. You need to comply with the rules too. So when I say
costs money, that costs money.
It can. It doesn't have to be that expensive. Most of the rules are actually fairly simple. Make use of we have a similar rule in aviation, right? You're supposed to, as a pilot in command, you're supposed to make use of all available information for the safety of flight, right?
Right.
Well, you should use all available information to make sure your active satellite doesn't hit something. That should be a rule. There should be a rule that says if your satellite dies, you need to deorbit it.
Right.
There's a rule that says it needs to come down naturally within 25 years. That's too long. You need to actually deorbit it or have it naturally, if it's naturally comes down in a fast time, that could work too.
Right.
We need to set a more realistic number than 25 years.
But I know, but we don't have that. But let me know. I know you have a drop dead date. Just tell me when we're done. But the point is, you're saying that you should design satellites that save some fuel to deorbit itself, that have the reliability that it's not going to just die. Those things cost money.
Yes, but in the same way that all the safety features on all of those commercial airliners, they cost money. But in the end, because the whole system is more reliable and usable by many, it saves money.
Sort of. I see this as a moral hazard.
It's like that we could have, look at the accident rates from the 1950s. Airliners crashed a lot.
but they have that. It really is in their best interest to not crash. Boeing just crashed the Max, and that really hurt the company.
Yeah,
But
yeah.
if a satellite crashes, like if
yeah, there's a bit of
GFC,
tragedy of the commons going on here. You're correct.
yeah, there's a moral hazard here where
Yeah,
they
yeah,
take the risk, and the rest of it, if we're not going to lose GPS because those satellites are at high altitude, but we could, if there was a shooting war at GPS altitude, I mean, that could be bad, right?
yeah. That could be intentional. That's true.
Because GPS is up at what, 5 or 10,000 miles or something.
Yeah, it's like 10,000 miles. Yeah,
they're pretty high up. The other question is, who pays for this? Debris
again, I don't think, remember that the cost of spacecraft is not driven by the like putting thrusters on it and that sort of stuff. To a zero Earth order, spacecraft is free. This is the way the businesses work. Almost all your money goes into salaries of engineers, okay, and your cost of borrowing money to launch constellations. Far and away the biggest cost is the finance cost.
Cost of capital. Yeah.
Cost of capital. Okay, so just like other things, that's the lever, right? It's insurance requirements and it's in regulations, right? It's regulatory reasons. That's why people comply with things, and that's the way to attack it. You're right. There needs to be some rules.
Yeah, we need a true international organization with teeth. It made aviation safe. Global shipping, passports. There's lots of international conventions.
Remember how those started? Those did not start with a global international rule. Right. Those started with national rules, which merged.
Right.
And I think I suspect that's the way it's going to happen. I think the United States could start out by doing this. We should.
Do we have that now? Is SpaceX required by the FCC to have a certain,
Yes, they have to file a plan on that includes a debris section.
End of life care, or if
yes,
you will.
They do. Okay. But the requirement is only 25 years.
Right.
But SpaceX decided to comply with it in a really I think ingenious way, with just to lower the altitude.
Yeah. But that costs money, because now they have to burn, the lower you are, the more often you have to replace your satellites, right? So
again, they're far and away their largest cost is not that. It's way in the noise. Far and away their largest cost is financing.
But you're financing rockets and satellites. I mean, the more rockets and satellites you have,
you'd be surprised at how inexpensive those satellites are, Jerry.
Okay. I mean, it's a private company, so I don't know.
I think you'd be surprised at how inexpensive those satellites are.
Yeah, but they're launching. How many are going to go on the BFR? Like thousands, or?
I don't know. They've got a new design that's larger, so I don't know how many.
A lot.
The new Starlink spacecraft are much larger.
I'm glad they have them. That's it's helping the guys in Ukraine get Russian interference-free internet. And I love what you guys are doing.
Yeah, I think the thing that's interesting is the most egregious operators are actually not Starlink. It's not even close. There's others. I won't name names here, but we do know the risks out there.
Right.
And Starlink happens to be one that people talk about a lot.
Right.
They're probably the best at it, though. At reduced collision risk, simply because they're lower altitude and things like that.
And they're using you guys. I mean, and what you're doing is really super beneficial. I mean, that allows them to manage that debris.
Yeah. Actually, we're doing pretty well on that front. LeoLabs doing quite well. 60% of all spacecraft in space now, almost 70% now, are actually use LeoLabs as their service provider.
Wow. You guys are like the Amazon of space tracking.
Well, space tracking is a little smaller world than Amazon, but yeah.
Your revenue is not the same number of zeros.
No.
that it's still a very cool thing, and it's very important. And like, the movie Gravity, or the Kessler syndrome, where one satellite hits another satellite, and that hits 5 more satellites, and that hits. Well, is that an issue? And if so, again, in my mind, it always comes down to the altitude, if it's going to stay there forever.
Yeah, it's a combination of altitude and the density of stuff up there. You have to have in order for that to really take off, we're not there yet. I mean, not that we couldn't get there, but I think if we act now, again, put some regulations in place, track things better, take away the biggest things, I think we can, we're orders of magnitude below where that becomes a giant issue. So we need to stay below it.
The good news is the higher up you go, the bigger issue, because the debris stays there forever. But it's also a lot bigger space, and it's a lot harder to run it. The odds go down.
And there's less also active satellites up there.
Right. Geo. Let's talk about Geo real quick. Satellites that are about 25,000 miles or something away. They're orbiting near the equator, and ironically, even though it's really far away, and you'd think there's lots of space out there, that's actually pretty crowded because all the satellites go to the same spot.
Yeah, they're all in a thin, narrow little belt around the Earth. But the good thing is there that the velocities are these things drift very slowly with respect to each other. So remember that they're all like moving around the Earth in the same direction, roughly at the same speed. So there's, in the same way that if you're on a highway going 60 miles an hour and everyone's on the highway going 60 miles an hour, you can do that, right?
Right.
But in low Earth orbit, everybody's going on a different orbit, and you're all going in different directions.
Remember League City?
Collision hazard's really in low Earth orbit, not Geo. There's other things going on, and it's more sort of espionage related things going on.
Up at really high altitude.
Yes.
You know what would be really cool? An astronaut mission I'd love to go on 1,000 years from now. I think it would be cool to go out. Those satellites, when they're done, they go to like a death orbit, right?
A graveyard. They boost them up higher.
Right. They climb up to 40,000 miles or whatever it is. And then they're just dead out there. No one cares. It would be really cool to go see what's out there, like a lot, centuries in the future. It'd be like an archaeology mission. That would be cool.
Yeah, I agree with you. One last thing before I have to run, but that's probably one of the coolest space missions was Apollo 12, because they got to land next to Surveyor. And after they got up, they went and found it.
Right.
There's a picture of Pete Conrad standing next to Surveyor on the surface of the moon, which was pretty cool.
That I know. And I heard that when they brought it back, they found that bacteria had survived. So NASA launched this probe, it landed on the moon, and then the Apollo astronauts landed next to it. And I remember hearing that the bacteria actually survived for, months or years in the...
I had not heard that. Wow.
Yeah. Anyway, thank you so much, Ed. What you guys are doing at LeoLabs is really cool. I think it's important for humanity. I mean, we need space for communication, for weather, for military reasons. There's a lot of reasons we need space, and you guys enable that.
And thanks for letting me show my little graphics and stuff. And and thanks for inviting me on the show, Terry.
Yeah, for those who are listening, again, the website is LeoLabs, LeoLabs.space. Is that right? And
that's
or
correct.
you can Google LeoLabs and you'll find it. It's really cool. It's a really cool tool. Okay. Well, thanks for coming on, Ed.
See you, Terry.
See ya.